Okay, so I'm going to go over some of the unique capabilities of edge computing. And edge computing has a number of capabilities around speed, reliability, privacy, governance, and bandwidth utilization. And today I'm going to go into the first two. So the unique capabilities of edge computing around the speed of the system and the reliability of the system using this architecture. And to do that, I'm going to compare the capabilities of edge computing in relation to a cloud computing architecture. So, cloud computing architecture utilizes computing resources in a centralized infrastructure in the cloud. And edge computing uses compute resources in decentralized infrastructure at the edge of the network. And so let's look at each of these architectures side by side and the differences between them. So in both of these architectures, you have centralized cloud environments that house compute and storage. And what I have set up here is I have cloud computing architecture on the left, and then two common edge computing architectures on the right. The one labeled two-tier, we call that mobile a lot of the times, is has centralized data resources and then a device tier. And then the second one is N tier. So this is going to have more than two tiers. And we talk about that a lot of the times as an edge architecture. So all three of those are the same as far as when you look at the cloud. So let's move that forward one tier. So now let's look at the device side. So they're all identical from a device side also. So you have data and web services and applications that are running in the cloud, and then you have devices, applications that are running on devices. So that could be a phone, a tablet, an embedded system, an IoT device running at the edge. So all of these are the same in both of those ways. And then on the edge computing side, you have capabilities that just don't exist in cloud computing. So in cloud computing, you have cloud data center, you have the wide area network or the internet, and then you have the device accessing that via the applications. In edge computing, you have the cloud environment and the internet connectivity. And then on the device side, you have this additional networking layer. So you have the ability to utilize the network at the edge. So that could be a private area network that is two devices creating an ad hoc network using Bluetooth or some other local technology, or a LAN. So they could just be utilizing a shared network, whether that's a hotspot or just a local LAN in some location. And they're communicating. They can use that network to communicate directly with each other. All right, so you're utilizing more of the compute and networking at the edge when you're doing edge computing. And then if you look at the N tier architecture, you also get these additional tiers of compute and storage that are near the edge. And so in this case, we would have some compute. So that could be a web service or an application, in addition to storage, right? Because most web services and applications have data that backs that. So you're going to have both of those things in that edge data center. And then you're going to have another networking layer. So that could be a wide area network again, like you could be connecting to an edge data center that's in a metropolitan area and connecting to that over the internet. Or you could have an edge data center deployed, say, on premise in a retail store or something like that, where you're using the LAN between the devices to connect to that near edge data center. So that's the architecture. Now let's look at the capabilities. So let's start with reliability. And so this is a simulation of how the system will behave under different real world conditions. So what I have it set out right now is just everything in the system is working as designed and as expected. So all systems are green. And in this scenario, you have the applications on the cloud computing architecture accessing the cloud environment and getting pretty quick access to that data. And then you have the edge computing environments also accessing that cloud environment, but they're moving data and compute towards the edge, right? And their ability to do that, so get compute and get data and get the interaction points of the system as close to the edge as possible, allows them to be faster than any other architecture. So, and if we then move this forward to a system that's operating okay, but it's operating slowly, right? So the cloud is slow, whether that's systems are undersized or overutilized, or the network is congested, but the cloud is running slower. And so in that case, the cloud computing applications, so that the devices that are utilizing the cloud computing storage to run the application are going to slow down also, right? But the edge computing architectures, the devices and applications that utilize the cloud but don't depend on the cloud for its compute and data are able to operate at full speed. Now, if we take that cloud computing environment offline, the cloud architecture apps are going to go offline. So this is where you see, uh, internet not available, try back later, or something went wrong, try back later. These are the types of errors you see when you're utilizing an app that where the cloud computing environment is not available, and it depends on that. Whereas the edge computing environment, they've moved these architectures move the data and move the compute towards the edge, so they're able to continue to operate with full functionality and full speed while the cloud computing environment is offline. So if we take this down even more on the end tier side, where that edge data center is operating slowly, it has no effect on the edge devices, right? That depend on it, they can continue to operate at full speed. And then if we take that offline, continue to operate at full speed, and if we actually completely disconnect them from the network, so you have a distributed architecture where you have complete disconnection of the applications from the rest of the architecture, edge computing can continue to operate. And that's because the compute and the storage, the data that the application needs, has been moved to the edge. So the networking is not required for the application to continue working. So now, under complete system failure, edge computing can continue to operate, which means it's going to be the most reliable architecture that you can use. All right. So now let's look at the second capability, which is speed. And so if we look back at that same architecture and we kind of look at what's going to control the speed of the application. So in a cloud computing architecture, the application needs to traverse the internet and access the cloud compute and cloud data for the application to function. And the typical latencies you're going to see in this type of setup is going to be like 300, 500 milliseconds. Of course, it could be lower, could be a lot slower, right? It could be faster than 300 milliseconds. It could be much slower than 500 milliseconds, especially under those conditions that I showed where the cloud computing environment might be slow or unavailable. But typical, green scenarios are going to be 300, 500 milliseconds for that type of architecture. And that's really just most of it based on distance. That cloud data center is kind of far away. All right, so it takes a while to get the data and then come back again. And with edge architecture, so I'm going to start on the end tier. So when you have a data center and your application is accessing that data center, and it depends on that data center for the data or compute, if it's in close proximity, so that could be like at the metropolitan area, if you have a device that's executing, say, in a city and there's an edge data center near it, you're going to get something like 5 to 50 milliseconds. And really the lower end of that, the 5 milliseconds, you're really going to need to have like an on-premise data center with wired LANs to get that low. And anything kind of in near proximity that you need to go across the internet, it's going to probably take more like 20, 30, 50 milliseconds to get to that. And then if you put the data directly on the device, and this is what I was showing before with the reliability where the entire system fails, but the devices are still running, well, those devices are deploying the data and the compute directly onto the application devices. And so for those, you can get guaranteed sub-millisecond response times because you're not traversing the internet at all. And so in addition to that 100% reliability, you get these very, very guaranteed fast speeds, regardless of internet connectivity or speed. And so if we look at edge computing unique capabilities, specifically focusing on speed and reliability, edge computing, very unique in its ability to get down to sub-millisecond levels, and very unique in its capabilities for getting reliability up to 100%. So hopefully that gives you a bit of an understanding of the unique capabilities of edge computing around its ability to deliver top speeds and high reliability, regardless of network connectivity and regardless of speed.